Let's get started. All right. This slide is about me. I'm a product leader. I currently work for a company called Apptio, which was acquired by IBM in 2023. Previously, I've worked at Amazon Web Services and Microsoft, both of which are two of the biggest providers of the public cloud or cloud computing in the world today. I've developed products for AWS and Microsoft that, cloud customers or enterprise customers can purchase and adopt, and many of them have been pretty successfully adopted. Um, Despite that I'm a product manager, my work is pretty technical. So I do in my day-to-day work combine both technical expertise as well as strategy to kind of deliver solutions for customers worldwide. Really excited to be sharing, my knowledge about cloud with you today and kind of how cloud can help us bridge the sustainability gap that exists in technology. So let's dive right into it. So as of today, we all know that not everyone uses the cloud. When I say not everyone, I mean, I'm talking about enterprises, companies, large, small, medium-sized. There is, cloud adoption has grown significantly over the last 10 years and is expected to grow through 2035 at a pretty rapid pace. Having said that, there still is an opportunity for so many enterprises to still adopt the cloud. What's happening today in terms of sustainability, which is really the core of what we're here to discuss today, right? Digital technologies they do consume a lot of power, a lot of energy. Global data centers, whether companies, even startups, are using them on their premises, they have their own data centers, or regardless of whether they're using the cloud as well, they use a lot of electricity. And this is expected to double by 2026, even from 2022. So that's pretty significant. What's driving this? Most companies today are really focused on how much data they gather. So a lot of processes involving data collection, analysis, to run their various applications require a lot of energy, electricity, and they're not exactly sustainable today. Add to this, all of you are familiar with how fast companies and individuals are adopting AI. So as far as enterprises are concerned, AI workloads are significantly contributing to being one of the main drivers of that energy consumption. And so that's definitely a challenge that, has to be resolved for. Engineers today are not necessarily thinking, you know, do I need to balance sustainability with my output? If they have to choose between accuracy of an application or reliability, scalability, etc., of the application versus how much energy or power the application is consuming, they're probably going to choose accuracy, reliability, scalability, etc., and not necessarily going to think about sustainability or how green their application is, which is somewhat unfortunate today. So we can talk about a couple of strategies that engineers and even users, you don't have to be an engineer to think about, sustainability in digital technologies. You can just be a user. There are ways in which you can use the data that's available today to try and be more sustainable. Okay, so can cloud computing help? So let's actually spend a few seconds on what cloud computing is. There are there are more than three players in the market, but three very prominent players in the market that today provide what's called the public cloud. And those companies are Amazon Web Services, Microsoft, and Google Cloud. There are other companies as well, many other, in fact, that offer cloud native solutions and applications. But these are the most well known, and they're essentially what form the public cloud. IBM and Oracle are also in the market, but they're smaller than the three that I mentioned. And they are essentially, what's driving cloud adoption by most enterprises globally today, especially across North America and Europe. I would say that AWS and Azure are probably the most, widely adopted. They are, as of today, providing users with a significant amount of data compared to before, um, in terms of, how can we be more sustainable? And when I say data, I'm talking about when if you're a user, they are providing you with information in your billing, such as, you know, um, can you utilize any of the metrics, from their billing files to kind of be more sustainable and understand what your carbon footprint is and that sort of thing. So that visibility is becoming more and more prominent, not just because the cloud providers want to provide it, but because a lot of companies today are under pressure to kind of be more sustainable. And this is seems to be one of their corporate goals at a high leadership level to kind of drive sustainability, which is really good for our planet. And hopefully this will continue. So yeah, as we proceed through this presentation, I'll talk about how cloud can potentially help these companies be more sustainable versus non-cloud technologies. So the challenge today, 4% of our global carbon emissions come from digital technologies. As I mentioned, we'll talk about tools that AWS, GCP, and Microsoft Azure are offering to users to make more sustainable choices. And there are also other, tools. Some of them are open source. Some are provided by other companies. In fact, I work for a company that actually does cloud cost management, and we also provide some tools for sustainability. And so the goal for these users is to aim for net zero carbon emissions, which is still a long way in terms of number of years, but hopefully we'll get there over the next decade or so. So here's a really easy quiz for you guys. What percentage of global carbon emissions is estimated to come from digital technologies?
Okay. There seems to be a consensus that 4%.
Awesome. Yeah, I heard that actually. That's correct. Yeah, everyone got it right. 4%. Okay, so AWS, which is one of the largest providers of the public cloud, actually commissioned a study in 2023. They partnered with Accenture for this study. They utilized a couple of metrics that were sustainability related to kind of measure on-premise versus cloud deployments. And what the findings were from the study was that cloud workloads tend to be a little more energy efficient. They do have lower carbon intensity. Uh, while their study focused on AWS cloud, I think there are several documents on the internet which kind of show pretty comparable results as far as GCP as well as Microsoft Azure are concerned. So why is this the case? I would say the main reason is cloud infrastructures, whether you're using, servers, storage, compute technologies for AI, GPUs, which, large companies such as NVIDIA provides. Cloud infrastructure is designed to be more optimal in terms of energy usage versus anything that you might build within your company on premises. And the only reason for this is because, a lot of their components are manufactured at scale, purpose-built silicon servers, which have higher utilization rates. And they also allow for economies of scale, meaning if your data grows and expands, the cloud is much more capable of being able to balance that and manage those economies of scales better than on-premise servers and on-premise data centers as of today. And that's what the cloud providers are saying as well. So just to go a little more in detail on what the study was based on, AWS and Accenture tried to focus on two types of workloads, storage heavy workloads, meaning um, workloads that require, have a lot of data from an enterprise perspective and require a lot of storage capacity and are also compute heavy. And when I say compute heavy, I mean require a lot of compute capacity. So servers, virtual machines, and everything else that requires computing in the cloud. So what did this study kind of show us? Here's a little more detail about that. Um, so some of the metrics that I mentioned in the previous slide are actually listed out here. They used power usage effectiveness and even idle capacity as two of the key metrics to kind of measure the study across. And they selected a few different use cases centered around the storage heavy and compute heavy themes. And what the results showed was that cloud managed storage service with carbon-free energy procurement was nearly 88% lower carbon emissions and up to 2.5 times more energy efficient than systems that were on premises. So yeah, this was really interesting to see how AWS's customers were definitely being or had a smaller carbon footprint while after they adopted the cloud versus before when they had their own on-premise data. There are regional variations. So let's only mainly talk about the United States and EMEA or Europe because I believe that's where the audience is from today. Focusing on carbon reduction opportunity for storage workloads, there is some kind of a gap between on-premise data centers and cloud data centers. And cloud data centers in this case are also showing us that, they're definitely more sustainable. Sorry, let's focus on the United States here for a little bit. This image that you're seeing on my slide is mainly for the United States and Canada. So what are those main drivers that are resulting in the cloud being more energy efficient? Hardware efficiency is one of the biggest drivers, driving about 18%. Power and cooling efficiency is huge. Now, this is an area that I worked on about 5 years ago or a little longer than that, I would say. Data centers actually generate a lot of heat because they are so, energy intensive. They require a lot of cooling mechanisms following the amount of power that they use. In fact, Microsoft actually was thinking, I don't know if they eventually did it or not, but they were thinking about building some of their data centers underwater just to manage the amount of heat generated, and the ocean would kind of cool the data center down much more efficiently than if the data center were above land. So that was one of the strategies that they were considering. Power and cooling equipment that cloud data centers use are kind of a big driver as well. And then there are tons of additional carbon-free energy components that are procured by companies like AWS and Microsoft. And many of these are, related to kind of the silicon that they use in their servers and that sort of thing. We can see that the Asia Pacific region has kind of similar results, showing that the cloud is actually also more sustainable. Key point to note here is that the APAC region, Japan, Australia, India, Singapore, they don't have the same kind of energy or sustainability rules, put in by their government that Europe does. I think Europe might be leading in this regard, but hopefully the other continents will follow soon. Despite that, we still see that, from these numbers that cloud is still a little more sustainable than on-premise data centers. If you've already adopted the cloud today and you're using AWS, Google, or Microsoft, there are many tools that, these cloud providers offer. We could potentially even look at one of them. The unfortunate thing is that, some of these tools, they don't currently, I hope you can still see my screen. I've kind of switched to an AWS. So
Yep.
AWS currently also, offers tools to for customers to kind of overview what their carbon footprint is. All of these cloud providers currently offer the same. So it's really interesting that they're doing this these days. One limitation that I've noticed is that if you are a multi-cloud adopter, meaning let's imagine that the university in Dublin here doesn't just use Microsoft Azure, but you also use Google Cloud Platform. So you've adopted two clouds for all of your software needs and applications, then you cannot measure your carbon footprint based on any one of these tools alone. So that's a limitation. So what we did, or my team did, is at IBM Cloudability, we actually built this. It's still loading, but we built this cloud sustainability reporting tool which kind of shows you a little more information. We're still developing it, but we have released, like for some of the most popular feature services in AWS, like EC2, EBS, and RDS, and Azure Compute and storage, etc. You are currently able to manage across cloud providers what your carbon footprint is. So this also helps you to be a little more sustainable. And what we're showing users is what your estimated carbon emissions are, so MTCO2e, and also your power consumed in kilowatt hours. So yeah, there are tools that various companies provide to kind of measure your carbon footprint these days. I want to do a quick pause here. Any questions so far?
Yeah. So can we ask yeah, far away, yeah, sure.
You mentioned the open source tools that are available. Can you, did you hear me or shall I repeat?
I'm so sorry. I actually did not hear that really well.
Oh,
I
okay.
just
Hi.
heard the word tools.
Shilpa, in one of your first slides, you mentioned open sources tools to measure and track emission from the clouds. Can you expand on that? And also, is the IBM compatibility reporting tool that you show, is it open source or it's by service?
Yeah.
Thank you.
So I haven't included any examples of the open source tools here. There is some open source information available where, if you are a user of any of the cloud vendors, you can, as of today, use open source to kind of build out applications where you can track your carbon footprint. I'm aware of that, and I'm happy to, after this conference, even maybe send some information through Damien or someone, because I haven't included the open source information specifically in my slides today. Having said that, I think one of your questions was also whether the IBM Cloud, Cloudability reporting capability is open source. Unfortunately, this is not open source. You do have to be a customer of IBM Cloudability to kind of have access to this. Yeah, this is not open source.
We have another question, Shilpa.
Okay.
Yeah, so it's more remarks because I mean, my company have a workload in all those three public clouds, and we want to compute our carbon footprint, but unfortunately, those tools are quite bad. Just to take the AWS example, it's impossible to have the scope 3, meaning the embedded emission within the Amazon web servers, the Amazon servers and machines, which is I mean, they should give that to us. And similarly for the scope 2, which is the electricity consumption, they value the electricity at the, I mean, it's market-based valuation, if you know the difference, which is also quite bad because we are obliged to reverse engineer their figure to obtain the real carbon footprint of the electricity. And even the renewable, I count it as zero, which is not the case. I mean, nothing has zero carbon footprint. So, and it's the case when you say we are using zero emission energy in the study. It's not zero emission. I mean, even in France, the location-based emission is around the hydro or whatever renewable emission. So, I mean, the fact is that those tools are quite bad at the moment. We should not say that they provide everything, and not to speak about the water footprint or other impact than carbon.
Yeah. So I just want to clarify, when you see these tools are quite bad, are you currently using the AWS tool and you don't like that tool? Is that what you're saying?
Sure. Yes. Yes. But our aim, because we are comparing all those tools because we are putting a lot of workload in those public clouds. So we must have the value to compute our own emission for our own services that we provide to our customers. So we use those tools, yes, and we lack plenty of information, like scope 3, for example, that I mentioned, or location-based emission. these kind of things. And we are forced to reverse engineer what they are doing to try to find out what are our own emissions using those public clouds.
Yeah. Uh, I mean, I'm gonna be honest and say that, sustainability is kind of a new thing. Even, when you look at the cloud billing data, like if you look at your AWS bill or Google Cloud bills, there are metrics and, some of the columns inside the bill, they are giving you some information about your energy consumption and your carbon footprint, but it's really difficult to understand them. And that's why we saw this business opportunity within IBM Cloudability to build and offer reporting capabilities that enable customers to understand their sustainability goals better. Unfortunately, even us, IBM Cloudability, as well as these major public cloud providers, everyone is behind in terms of sustainability. I don't think it's been like the number one goal in terms of what they want to offer to customers. But that is changing given the pressure on companies to be more sustainable now onward. So I think over the next 5 years, we might see more emphasis placed on sustainability and uh, enable users to track their carbon footprint. But there are still a lot of gaps. Having said that, there are information within the cloud providers' billing files, um, but exactly like you said, it requires a lot of like you have to extract that data, you have to use maybe tools outside of AWS to potentially analyze that specific data. So it's not very easy. And Cloudability is kind of aiming to offer that, for the sustainability use case as one of its use cases that it's targeting. But for none of these, including IBM Cloudability, sustainability is not like top of mind. But I think through these conversations and by kind of educating users a little more about how important sustainability is, that's likely to change. We're already seeing some shift towards kind of the emphasis that sustainability is getting. But hopefully that'll change in the next couple of years. But I 100% empathize with the pain point because I've seen that as well as I've spoken to other customers about this.
Shilpa, hi. We looking at measuring energy from servers, legacy servers, etc., and also virtual machines very accurately with some of the techniques that we've used here within UCD and also the campus company that we've got. We noticed also from a lot of the AWS and Google and also the IBM stuff, it's very specific to the platform it's designed for rather than legacy systems. And also the accuracy is not there. And if you initiate a virtual machine energy analysis is almost non-existent. And that's something we've managed to crack with our technology here.
Oh, what's that technology? That sounds pretty awesome.
Okay, well, if you have a look at our Beyon website, BEYON,
Okay.
it'll show you the techniques and tools that we used, and we're now using the methodology to move into working with AI tools as well to look at future-proofing our technology, which is at the moment matrix-based and audit-based, which is accurate because we've measured it against a Yokogawa meter to make sure that we have the right analysis for energy
Yeah.
compared to what we are expecting it to be. So our mathematical models, which uses a client on a server and also a virtual machine, is very accurate. And that's something we've failed to find anywhere commercially out there in the marketplace.
Wow, that's pretty awesome. Yeah, I mean, I'd love to, if we have like 5 minutes at the end of my presentation, maybe revisit this to ask how you kind of built this. I'm really curious, but yeah, would love to learn more. I kind of wrote down what you said about the website.
Yeah.
I'll definitely also take a look after this meeting.
Please do. And if you have any questions, get back to me. And it would be nice to have a conversation about how maybe we can collaborate in the future or maybe exchange ideas as well. Thanks for your time, Shilpa.
Yeah, that sounds great. I would love that.
Thanks, Abby. Yeah, I don't want to turn it into a commercial advertisement for our company. I'm the CEO of the company, but we can take that offline later on and discuss that with you, Shilpa. On a more general level, in Europe now, we have the Energy Efficiency Directive, And that now is mandatory for data centers over 500 kilowatts. And there's about 25 metrics you have to, and KPIs that you have to measure. PUE has been around for a long time, but even with the PUE 1, which is ideal, you can still have huge inefficiencies because it's just measuring how much energy is really being used by the complete data center. And if you, even with one, it means, as you know, all the energy is going to your servers, but if those servers are not really productive, you're still wasting energy. So I don't know what the situation is in America now. Things are changing quite a bit backwards, and I don't know whether it's going forwards. But do you have the same type of regulations in the States that it's being imposed on large data centers, that they have to show their performance, and it's like an audit, it's like an energy performance audit? Is that happening in America?
So there were some rules related to data centers that were exactly like you said, Damien, that were incorporated. I think it was in 2023, before Donald Trump became the president, that data centers had to follow very strict rules related to carbon emissions and so on and so forth. I'm not 100% sure about what the latest is, but even back in 2023, and when I used to work at Amazon Web Services, I was super familiar with the data centers being constructed in Dublin because they were in progress at that time. Maybe they're completed at this point from an AWS standpoint, but I do remember us talking about how sustainability and maybe not just the Irish government, but also Europe in general had much more stringent rules as far as energy consumptions and emissions were concerned. I think America was actually a little behind Europe at that point, but they were catching up in 2023. I'm not 100% sure what the latest is. I still feel like, just based on the data that I showed in some of my previous slides, that Europe is still ahead in terms of some of these guidelines from the governments.
Sure. Yeah.
Something
And do you find
that
customers? Sorry, Supriya, go ahead.
No, I was just saying something that I really find interesting is that how these big companies release their data related to how renewable their data centers are. So basically, I've seen at least some organizations making choices based on that, on like where should we host our applications, which is very interesting to me.
Right, because that was the question I was going to ask. How much of this sustainability is being driven by your customers? Demanding, they want their scope 3 to be
Yeah.
accurate, and they have to report it. And are they actually saying to you, "Can you tell us what the scope 3 is, so we can put it into our annual report"? Is that happening? Are companies asking those questions?
That's a great question. So from a leadership or very high level strategy perspective, I would say, and Supriya, feel free to chime in here, but I would say that in the US, at least, a lot of companies from a strategy perspective do have very specific sustainability goals these days. Having said that, how much is that really translated to the engineers who are working in the weeds on a daily basis and building these applications and managing, maintaining these applications? I'm not 100% sure that it's translating into the everyday efforts and everyday work. But at a leadership and strategic level, the companies are, maybe more than 5 years ago, reporting out on sustainability goals and results and tracking metrics, etc.
Okay, it's good to see. So there's another question here. Let's move here. Is it okay to take a question? Yeah. Is it okay? Yeah, I'm not
Yeah.
interrupting. No. Yeah, okay. So
Yeah, that's fine.
Hello, interesting, very interesting data. As from like a young kind of perspective, there's a kind of public perception, especially from that like these data centers like use a lot of energy and a lot of water to kind of cool them. So is it an interesting data? Because I was under the impression that like they were quite inefficient. So like if they are better than the kind of in-house, how do you kind of translate that into public perception? Because it is seen by people like young people as just like a waste, like a large use of energy and a large use of water, especially for like cooling systems, and kind of taken away from other resources. So there's a lot of resistance for like governments to like put them, like there's a lot of resistance in Ireland especially. So I'm wondering how you kind of deal with that and kind of make them even more sustainable afterwards.
Yeah, I mean, that's a really tough, problem to solve, the perception. And there is a lot of truth to the fact that, from a carbon footprint and emissions perspective, digital technologies, especially with the adoption of AI, how much energy we consume, how our carbon footprint is going to grow is definitely going to continue to grow. And when I worked at Amazon Web Services, I actually had a colleague who was based in Dublin, and his daughter was absolutely against the fact that her own dad used to work in the data center space. Like, she was kind of angry about it. So I do understand kind of how the young people have this increased perception of how it isn't supportive of us having a very green planet, and they're not sustainable. Having said that, I also feel like, as you know, most young people today adopt technology much more than the older generations, that they're using social media, artificial intelligence, and that's not going to change. I feel like it's not going to go anywhere. So I think this is just my opinion, and I'm seeing more and more companies kind of, try to be more sustainable as well. Maybe not at the pace that we would all like, but they are improving. Having said that, I think that, one of the best ways is, since AI is not going to go anywhere, it's only going to continue to grow worldwide, including everywhere in the world. The best thing that we can do is try to understand how we as users could maybe contribute to sustainability exactly through discussions like these. Like, I was going to talk about in some of my future slides how, if you work at a company, you're trying to build a really large application, you can actually think about which data centers you can use. You can choose data centers for your data to reside and be analyzed out of, like, for example, Ireland or somewhere in Europe versus North America, where, the sustainability or carbon footprint goals and things like that are not as good as Europe. Europe is slightly better. So you can say, I want all of my analysis and compute to be done out of a data center in Europe so that I'm being more sustainable. So I think just having the information through discussions like this and through information that cloud providers are putting out today is maybe the best way to kind of change that perspective and also improve awareness. Um, and yeah, just talk about it more and more, and that will in turn pressure companies to try to find and identify ways to be more carbon negative. I can tell you that Microsoft Azure and Google Cloud are also, if you go on their websites these days, they are talking a lot about aiming for, to be at least carbon zero or carbon negative. If not now, in the coming years, they do have very specific targets around that. So yeah, I think it's definitely more on young people to continue to keep talking about this, continue to talk about how AI is only going to drive increased power, usage. But what can we do? What choices can we make to kind of continue to improve that? Hopefully that answers your question. I know it's not a simple thing to solve for.
Okay, thanks, Shilpa. Any other questions before we continue on? Sorry.
Short question. Okay, thank you, Shilpa. Interesting. So my question is, many companies narrates that there is lack of the standardized tools for measuring their energy consumptions, and but still we have the tools available from Amazon or from Google. But many companies still narrates that there is lack of standardized tool. So are they talking about the hardware level or the software level tools? And secondly, there is lack of awareness in the industry regarding the environmental impact of this software. So what strategy should the countries or the organization apply to enhance and get the good practices and their setup to make the software less energy consumption?
Yeah, so I'll answer your first question. So I would say that the tools, or the tools that AWS and the other companies are putting out there, they do measure or track carbon emissions from both hardware and software perspective. Mainly, I mean, your carbon emissions are driven by data centers, right? That's where, running your servers, storing your data, those are the things that is driving power consumption. And so your metrics are mainly going to be based off of those. And that is the same data that they're providing in their billing files these days to customers to provide visibility into this. And so some of these tools, like I showed in this slide, are based exactly off of that. So they're really measuring the hardware and providing data on that. This slide also shows you kind of hardware efficiency and power and cooling. It's all based on the components and hardware used in the data centers that's really driving how much power your software is consuming. So hopefully that answers your question. And I think your second question was similar to one of the questions. Correct me if I'm wrong, but the previous question that I received from one of the other participants, which is how can we continue to increase awareness? Is that what you asked?
Yes.
Yeah, I mean, kind of like I addressed before, I think through conversations like these, and if you work within companies that are building software applications, definitely continue to ask, in addition to focusing on workloads, accuracy, scalability, reliability of software, are we also thinking about sustainability as a metric? And that's something that needs to be incorporated even at the engineer level, even at, the entry level software engineer that's building these applications, not just at the leadership or high level strategy level. I think that's really when we're going to start seeing change happen at a more rapid pace.
So me and Shilpa actually very recently we worked on this research where we got this data from a lot of industry professionals about like were they actually looking at sustainability data when they were working on software, and what we found what the results that we found were they were actually not. The primary goal like they were trying to achieve was cost, either reducing cost or trying to go for performance or just delivering features faster. Not Very few people like almost like negligible were like thinking about sustainability, at least in the United States at this time. So hopefully as companies move more and more towards like thinking about sustainability at a leadership level, that's where it will start trickling down to our engineers as well.
Yeah, absolutely.
Okay, thanks. Anything else you want to move on to? Okay, do you want to move on to your next set
Yeah, sounds good.
Yeah, okay, move ahead. Thank you.
Thanks, Damien. Okay, so here's a question. Which of these following tools do you think, or can you even guess, can be used to track carbon emissions in AWS?
C, AWS customer carbon footprint tool, C.
Okay.
C seems to be the answer.
Yeah, you guys don't need this workshop. You already know. Okay, so here's one strategy that I wanted to discuss. If you currently use any of the cloud providers, what are some ways that you can schedule your workloads so that you become more sustainable? So you can shift your workloads to times and regions with lower carbon intensity. I think this is one of the most not influential is not the right word, but most results oriented thing that you can do. You can say, I'm going to host my data in a Dublin data center versus a San Jose, California data center, because Dublin, the government has better policies around power usage and carbon emissions and that sort of thing. So by doing that, you're already focusing on being more sustainable. You can also defer to any kind of non-urgent processing to optimize your workloads. So if something is not super urgent and doesn't have to be processed on a real-time basis, you can say, I'm going to focus on running this workload in the middle of the night when traffic or software traffic, data traffic is minimal, and it's going to use less power at that time. So, this slide is really focusing on multiple strategies that can be utilized to enable software engineers and other users to essentially minimize their carbon footprint. Resource right sizing and optimization. So this is a strategy that only the cloud providers are offering today. I don't think that, I could be wrong about this, but I don't think that software engineers or enterprises that have data centers on premises can potentially use right sizing as a strategy to potentially lower their resource utilization, and therefore their energy consumption. So cloud often makes suggestions on how you can utilize your resources to definitely reduce or optimize for the best case scenario your resources in the cloud. So they can say instead of using, five servers or 10 virtual machines to run a specific application, you can use a smaller number, or you can use the servers and virtual machines differently, and that sort of thing. So just keeping it super high level here, but the cloud can make recommendations like this, and this is what is right sizing and optimization. So all three of the major cloud providers are currently providing this kind of right sizing information and data-driven right sizing. So this is definitely going to help software applications be more sustainable. Okay. Here's another one for you guys. What is a major limitation of the cloud provider sustainability tools like AWS and GCP? Okay, I heard B.
B, C sort of conflict here, B or C. Okay.
Yeah, you know what? You're actually right. I think it's also B. My answer needs to be updated here. Yeah, you do have to be you do have to be a user, a paid subscriber.
We have a very educated audience here this afternoon.
Yeah, you really do. Absolutely. Okay. What's a
Just on that, sorry, Shilpa, just like in Ireland, we have we have in our national grid, we have a composition of green energy when there's enough wind, and it's very variable depending upon the climatic conditions and day to day. So if we were to do like move processes around, we'd have to really take into account like what is the weather today, whether the carbon, the carbon intensity of the energy we're using is up or down compared to another location. So it's quite a complex thing to do in Europe. It's okay for a country like, say, Norway, where it's all renewable, so it's 100% green. But a lot of countries, it varies according to loading and climatic conditions. So taking those into account and shifting loads around would be quite a complex task.
Yeah, no, you're absolutely right. And I think that's definitely one of the challenges that APAC, for example, where a lot of the energy resources are not renewable. One of the reasons is also some of those APAC countries like Singapore, India, they're all based geographically in regions where the weather is, tropical or really warm compared to Europe and Norway, for example. I think that's also a significant challenge in terms of how sustainable they can be versus some of the cooler countries. Iceland, for example, was being considered as a really good site for data centers just because of their climate and the resources that they have there. So yeah, but unfortunately, I think data centers do need to be constructed all over the world for usage by enterprise and non-enterprise customers globally. But yeah, APAC is really, I think, challenged by the weather and climate in those regions. So yeah.
And also, I think you mentioned there about zombie servers, and I think that you have this figure. I think it is by the report by Kumi a few years ago that like 30% of servers are only used around 4% of the time, and even the average is only about sort of 20%. Would that be really representative of what is happening in hyperscalers? 'Cause I thought hyperscalers would be far more effective and efficient in how they load their servers because they have a more homogenized server base and it's easier to manage the system. So they've been pretty good. It's really the non-hyperscalers where you still have a lot of the issues.
Yeah, 100%. I mean, you kind of hit the nail on the head. There is so much opportunity for enterprises to kind of optimize how they're using their servers and virtual machines. And the cloud is getting better and better at doing this. And that's exactly what I was trying to kind of bring forth in the right sizing slide. So right sizing is a strategy that is only improving based on the data that cloud providers are collecting from enterprise users. So I think that will continue to improve. But maybe some of the engineers in the audience, or even Supriya, can correct me if I'm wrong when I say that I think this is a significant challenge on premises versus using the cloud.
Yeah. Okay. Thanks, Shilpa. Do we have another quiz now, do we?
Yeah, I think this is the last quiz that I have. So yeah, what is a key feature of carbon-aware
Please,
computing?
can we get 100% in our quizzes? Okay. Okay. To look at the quiz and see what the answers are. No. Oh. Everyone's going to say C anyway.
Yeah. Sorry, I accidentally hit it before. Yeah, but yeah, C is correct.
We knew the answer anyway.
Yeah. Okay. Yeah, I don't know if I know we only have about 9 minutes left, 10 minutes left. I'll come to this breakout session at the end if we have time, but I wanted to share, some of these case studies. I know the audience already seems to know a lot here, but there are success stories pretty recently where, specific customers, Stockholm Exergi is a Swedish company that recently managed to have some significant results that I've documented here in bullet number 3, about how they were able to reduce their carbon footprint migrating from local data centers or on-premises to the cloud. Another very successful example is Google Cloud itself. Google Cloud Google Cloud was actually the last large company to enter the cloud market. AWS and Azure were there before Google Cloud. But after Google Cloud made that entry, they actually migrated all of their cloud applications that they offer to customers to their own cloud, and they saw significant improvement in their energy usage and carbon emissions. And even customers that use Gmail, within their enterprise saw, the ones that were measuring it saw decreased environmental impact compared to running email on their local servers. So these are just some examples of case studies that, where companies have shown significant improvement. Yeah, in conclusion, I think based on the data, we're definitely seeing that migrating on-premise workloads to the cloud can definitely help achieve better hardware utilization, better power and cooling efficiencies, and consequently, better carbon, the ability to have a smaller carbon footprint. And then using optimized configurations, this comes back to right-sizing opportunities that cloud offers. Cloud offers hardware optimization and so on and so forth, which can also have a positive impact. And finally, the regional variations in data centers. And this is something that I'm not sure how many people actually implement on a day-to-day basis, like choosing to store your data in regions around the world where the policies around carbon emissions and power consumption are significantly better than maybe in your own specific region. So yeah, this can have a significant impact. So just having the knowledge and education about this also helps. So I hope that people will start wanting to learn more about this and implement some of these strategies. So that's all that I had. We can move on to Supriya's portion of the presentation.
Sure. Yeah. Thanks, Shilpa. That's excellent. Thanks very much.
Yeah, thank you so much. I really appreciate all of the engagement and the questions. I really enjoyed sharing this with all of you, and thank you, Damien, for the opportunity.
Thank you. And where are you located? Are you in Silicon Valley, or where was this transmitted from?
I'm in Seattle, so on the West Coast.
On the West Coast. Okay. Yeah. Well, anyway, thanks. It's a bit early in the morning there, I guess, and it's getting late in the day here, but we appreciate your time there, Shilpa. Thanks very much.
Yeah, no, it's been an honor, so thank you.
Thank you.